Okay, so these are the solutions for the exam on differential calculus. Start with question one. Question one says f of x is equal to x squared minus k over x, which I will immediately write as x squared minus kx to the negative 1 power. Part A, write down f prime of x. The derivative of x squared is 2x minus k times the derivative of x to the negative 1 is negative 1x to the negative 2. So 2x minus negative becomes plus kx to the negative 2, or k over x squared. Part B, the equation of the tangent to the graph of y equals f of x at x equals negative 2. So the tangent at x equals negative 2 is 2y equals 4 minus 5x, which I will immediately write as y equals negative 5 over 2 x plus 2. So I'll divide both sides by 2 and rearrange the right side. So why do I do that? Because I want the gradient of the tangent. Well, the gradient, the slope, is just the number in front of the x, negative 5 over 2. C says find the value at k. Well, f prime of negative 2 is both negative 5 over 2, because it's the tangent line. It's also 2 times negative 2 plus k over negative 2 squared, which is the formula for the derivative. So negative 5 over 2 equals negative 4 plus k over 4. Add 4, i.e. add 8 over 2 to both sides. I get 3 over 2 equals k over 4. Cross multiply, 12 equals 2k, divide by 2, and I get k is equal to 6. So that's question number 1. Question number 2. We have the function f of x is equal to 1/3 x cubed plus 1/2 x squared plus kx plus 5. It has a local maximum and a local minimum, and the local maximum is at x equals negative 3. And they want to show in part A that k must be negative 6. Well, if there's a local maximum at x equals negative 3, the derivative must be 0 at x equals negative 3. Again, this is a SL conclusion, even I think an HL conclusion, but at a more advanced level, not necessarily true, but for SL it is. So f prime of x, if I take the derivative, the 3 comes down and cancels the 1/3, drops by 1, so x squared. The 2 comes down, cancels the 1/2, drops by 1, plus x. Kx plus 5 is linear, so I just get plus k. And I know that f prime of negative 3, which is negative 3 squared plus negative 3 plus k, or 9 minus 3 plus k, or 6 plus k, must be 0, telling me that k is equal to negative 6. Part B, find the coordinates of the local minimum. Well, we know that there's a maximum at x equals negative 3. They told me that. So what I'm going to do is, of course, now I know that f prime of x is equal to x squared plus x minus 6, because k is negative 6. If I set this equal to 0 and solve, I can factor, and I get x plus 3, x minus 2 is equal to 0, telling me that x equals negative 3 and 2, or 2. X equals negative 3, I already know gives me the maximum. So 2 must give me the minimum, because they were so nice to tell me that there's a local max and a local min. So the minimum, the local minimum, is at 2 comma 2 comma what? Well, let's go back to the original equation. 2 comma 1/3 2 cubed, it's 8/3 plus 1/2 of 2 squared. 1/2 of 4 is 2. Remember, k is negative 6, so minus 6x minus 6 times 2 is minus 12 plus 5, or 2 comma 2 plus 5, 7 minus 12, negative 5, negative 15 over 3, 8 minus 15 over 3, negative 7 over 3. And now for C, write down the interval where the gradient of the graph is negative. Well, if I make my number line for my f prime number line, I already know that at negative 3 and 2, it's 0. I also know that -3 was a maximum and that 2 was a minimum. I don't have to plug anything in because they gave me that information. So where is the graph, where's the gradient negative? From -3 to 2. No further information or math required for that one. Next one is, no, we're not done yet. Next is 2D. And part D says, determine the equation of the normal at x equals -2. Okay, x equals -2, not x equals +2. So let's find the derivative at -2. If I go back to my f prime of x, I get -2 squared plus -2 plus k, which we already know is -6 plus -6. -2 squared is 4. 4 minus 2 minus 6. That's -4. So the derivative at -2 is -4. So the slope of the normal is the negative reciprocal of that. The slope of the normal is going to be +1/4. Of course, I need to know what the y value is at -2. So -2 cubed is -8. So I get -8/3. -2 squared is 4/2 plus 2. -6 times -2 is +12 plus 5. 12 plus 2, 14 plus 5 is 19. 19 times 3 is 57. 57 minus 8 is 49. So, I mean, I'm going quick because I want to get this done fast. I might make a silly math mistake. I think it's 49/3, and therefore the equation of the normal line is y minus 49/3 equals 1/4 x minus -2, which of course you can put, oh, and they say in the form y equals mx plus c, so we have to. So y equals 1/4 x plus 1/4 of 2 is 1/2 plus 49/3. Oh, so 1/4 x, 1/2 is 3/6, 49/3 is 98/6. So if I did my math correctly, I get 1/4 x plus 101/6. Maybe I did the math wrong. I don't know. The number doesn't look familiar when I graded it, but that's certainly the right strategy. Again, just trying to go quick here. Question 3. We have f of t is equal to 1,000 over 1 plus 24e to the -0.2 t power, specifically for t values between 0 and 30. It says the population of fish in a lake is modeled by this function, where t is measured in months. A, find the population of fish at t equals 10. Well, I'll just plug t equals 10 into my calculator. I get 1,000 divided by parentheses 1 plus 24 times e to the power of -0.2 times 10. And that gives me, f of 10 gives me 235.4. Of course, you can't have 0.4 fish. So I'm going to round this to 235 fish. B, find the rate at which the population of fish is increasing at t equals 10. Well, for this, the rate of change is the derivative. So this is not something that SL can handle, which is why I gave it, because it's a calculator problem. Y equals 1,000 divided by parentheses 1 plus 24 times e to the power of -0.2 x, and parentheses, let's graph it. Okay, let's zoom standard because I don't see it. Oh, there it is now. Okay, but I gotta zoom out. So zoom out. I gotta evaluate this at 10. So I have to make sure that my window is large enough to have the graph at 10. I still don't see it, so I'm gonna zoom out again. And now it's there, but it's really high up. So I'm gonna move my cursor really high up, and I'm going to do a zoom box, and I'm going to make my box before 10. Okay, and go down a little bit across. Okay, let's zoom in here. Essentially, I'm just adjusting my window so I can see it. Okay, so x min, actually, there's an easier way. What am I thinking? I already know the y value is 235. So I'm going to do an x min of 9 and an x max of 11. That will certainly cover 10. And a y min of 230 and a y max of 240. Because I know that it's a 10, it's a 2, and there it is, right? Okay, I zoomed in. Now, x equals 10 and y equals 235. I'm going to hit second calculate and ask it to compute dy over dx. And I get that dy over dx is approximately 36. And it's going to be fish, which fish per month, because it's a rate of change. At t equals 10, I did dy over dx, but to be honest, it should be dy over dt is approximately 36 fish per month. C, find the value of t for which the population of fish is increasing most rapidly. Where is the derivative the maximum? So for this, I'm going to do a window. I'm going to do 0 to 30 for x, because remember, all I care about is 0 to 30. And I'm going to do a y min from 0 to, let's say, 1,000. Okay. So when I look at the graph, it looks like this. And you can kind of look just by looking at the graph, it's the derivative is relatively shallow, then it steepens out, and then it becomes shallow again. So right there in the center seems to be where this graph is the steepest. So I'm going to zoom in and try to get a better approximation. Yeah, okay. So I get a value at about 15, which is halfway. If I'm going to zoom out again, I'm trying to think if there's a better way of doing this, because you can't actually, oh, you know what? No, you can't do it that way. Yeah, so this is just an approximation based upon the graph. And it seems like from the graph that it is increasing most rapidly at about 15, which is the halfway point. So for what value of t, I would say t is approximately 15. 1 second. Okay. Actually, looks closer to 16. So I'm going to say t is approximately 16 months. As a slightly better approximation. All right, question number 4. Consider the function f of x is equal to 1/3 x cubed plus 3/4 x squared minus x minus 1. Part A just says find f prime of x. 3 comes down, drops by 1. The 3's cancel. You get x squared plus 3 over 2x minus 1. Part B, find the gradient of the graph at x equals 2. Well, that just means plug in 2. 2 squared is 4 plus 3 half times 2 is 3 minus 1. We get 6. C, find the equation of the tangent line at x equals 2. Well, to that, we need the y value. We get 8/3 plus 3 minus 2 minus 1. 3 minus 2 minus 1 is 0, so we just get 8/3. So I get y minus 8/3 equals 6 parentheses x minus 1. But they want it in a very specific form, ax plus by plus d equals 0, where a, b, and d are integers. So I'm going to multiply everything by 3 to get rid of fractions. 3y minus 8 equals 18x minus 18. Let's get the x on the same side as the y. So negative 18x plus 3y plus 10 is equal to 0. Or if you want the leading term to be positive, 18x minus 3y minus 10 is equal to 0. Okay, question number 5. It says f of x is equal to x cubed minus 2x squared plus ax plus 6. Part of the graph of f is shown. So I'm going to graph what they have here, which looks something like this. And they have this point here labeled as P. And they have the minimum here labeled as Q. And then they have the tangent line at P. And this line goes through, and they call this L. So this is the problem. So it says part A, find the coordinates of P. Well, P is a y-intercept. That's just f of 0. We get 6. So the coordinates of P are 0, 6. B, find f prime of x. Okay, no problem. F prime of x is 3x squared minus 4x plus the currently unknown a. No problem. C, hence, that means as a result of what you've done before, find the equation of L, of the line, in terms of a. Well, it's the tangent line at 0. So f prime of 0 is a. That is the slope. So I get y minus 6 equals a x minus 0. So y equals ax plus 6. D. The graph of f has a local minimum at the point Q. L passes through Q. Find the value of a. So this is the 8-mark part. This is the heavy duty one. What do we do here? Well, what do I know about point Q? I know 2 things. I know 3 things. One, I know it's a local minimum, which means the derivative of f prime has to be 0. If I set the derivative of f prime equal to 0, though, I'll have 2 unknowns. I won't know a, and I won't know the x value. So if I can find the x value somehow, then I can plug it in and solve for a. So how do I do that? Well, first let's write what I have so far. F prime of Q, of point Q, which is currently unknown. I'll just say Q here, even though it's kind of a bad notation. But F prime of Q is equal to 3x squared minus 4x plus a, and this equals to 0. So that's my first equation. If I can solve for x, I can plug it in and solve for a. How do I solve for x? Well, there's 2 other things I know about point Q. I know it's on the curve, and it's also on the line. The curve was x cubed minus 2x squared plus ax plus 6. The line is y equals ax plus 6. These 2 things must be equal. If both of them are true, because the point is on both, their y values must be the same. So y equals x cubed minus 2x squared plus ax plus 6 has to equal y equals ax plus 6. The ax plus 6's cancel. I get x cubed minus 2x squared is equal to 0. If I factor out x squared, I get x squared times x minus 2 is equal to 0. And I solve, I get either x equals 2 or x equals 0. Now, I already know when x equals 0 that they coincide because that's the tangent line. So the other point must be 2. This must be the x value of 2. What is f prime of 2? 3 times 2 squared, that's 12, minus 4 times 2 minus 8, plus a is equal to 0. A therefore must be, a must be negative 4. A must equal negative 4. Question number 6. Haruka has an eco-friendly bag in the shape of a cuboid with width 12, length 36, and height 9, all centimeters. The bag is made from 5 rectangular pieces of cloth and is open at the top. Got a bottom, left, right, back, front, nothing on top. 6A. Calculate the area of cloth in centimeters squared of Haruka's bag. So it's again 12 by 36 by 9. The bottom, so the area, this is 6A. The area is, the bottom is 36 by 12. The right side is 12 by 9. And the left side is the same, so times 2. The front is 36 by 9, and the back is the same, so times 2. 5 sides, no top. Calculator problem, 36 times 12 plus 12 times 9 times 2 plus 36 times 9 times 2 gives me 1,296, and the units are square centimeters. B, calculate the volume. No problem. That's length times width times height. 36 times 12 times 9. That's 3,888. And this time it's cubic centimeters because it's a volume. Part C. Nanako decides to make her own eco-friendly bag in the shape of a cuboid, such that the surface area is minimized. The width of Nanako's bag is X. Its length is 3 times its width, and its height is Y. So when I draw Nanako's bag, I get X, 3X, and Y. And her volume is also 3888 cubic centimeters. Use this value to write down and simplify The equation in x and y for the volume. Well, the volume is 3x times y, or 3x squared y equals 3888. If I divide both sides by 3, I get x squared y equals 1296. And that is the simplified version of that one. And then it says, for part D, it says write down and simplify an expression in x and y for the area of the knuckles bag. Well, let's take a look. A is the bottom, which is 3x times x, or 3x squared, plus the right, which is x times y twice, so plus 2xy. And then the front is 3x times y, 3xy, and the back is the same, so plus 6xy. So here we have area equals 3x squared plus 2xy plus 6xy, or 3x squared plus 8xy. E. Use your answers to part C and D to show that the area is equal to 3x squared. Well, I have that. Plus 10,368 over x. Well, where'd the y go? No problem. Take this one here. Y equals 1296 over x squared. So instead of saying 8xy, it's 8x 1296 over x squared, which becomes 3x squared plus 1296 times 8 is in fact 10,368. And x over x squared. So I'm just verifying what they told me the answer should be. F, find the derivative of a with respect to x. No problem. 6x minus 10,368 over x squared. How did I do that? I brought the x to the top, x to the -1. Negative comes down, x to the -2. Flip it back to the bottom. G, use your answer to part F to show that the width of the knuckles bag is 12. Well, what do we do with the derivative? We set it equal to 0. So that gives me that 6x equals 10,368 over x squared. If I cross multiply, I get 6x cubed equals 10,368. 10,368 divided by 6 is a nice number. X cubed equals 1728. Well, let's try the cube root of this, and I get, x equals 12. And we're in centimeters. H, the cloth used to make the knuckles bag cost 4 yen, Japanese yen, JPY per square centimeter. Find the cost of the cloth to make a knuckles bag. Well, if I go back to E, I know the area is 3x squared plus 10,368 over x, but now that I have x is 12, I can do 3 times 12 squared, which is 144, plus 10,368 divided by 12. This gives me an area of 1296, which I seem, that's the same thing as x squared y, 1296. That's quite a coincidence. Or maybe not. I don't know. I'm not examining it. So the area is 1296. So what's the cost? Well, it's 1296 times 4 per square centimeter. So the cost in yen will be 5,184 Japanese yen. Nice problem. Optimization, always fun. Question 7. Consider the function f of x equals x cubed minus 3x squared plus 2x plus 2. Find f prime of x. No problem. 3x squared minus 6x plus 2. Notice that there were a lot of problems in this test. Just find the derivatives. You could have gotten a 2 on this exam only by answering the derivative ones without even knowing how to apply it to anything else. 3x squared minus 6x plus 2. B, there are 2 points at which the gradient of the graph is 11. Well, let's set the gradients equal to 11 and solve for what those 2 must be. So I get 3x squared minus 6x minus 9 is equal to 0. Divide both sides by 3. X squared minus 2x minus 3 is equal to 0. Is that factorable? Looks like it. X minus 3x plus 1 is equal to 0. So I get x equals -1 and 3. They just say find the x coordinates. So -1 and 3 and done. Don't even have to find the y coordinates. And then we have question 8. Y equals 2x to the 4th plus 6x cubed plus 7 over 2x squared minus 5x. Oop, ran out of room. Power of the iPad, make things smaller. Plus 3 over 2. Find the x coordinates of all points on this curve at which the tangent to the curve is parallel to the tangent at -1, 6. Well, let's start with finding the tangent at -1, 6. How do I find that? Well, let's take the derivative. Y prime equals 8x cubed plus 18x squared plus 7x minus 5. in a chapter on differential calculus, even if you don't know why to take the derivative, that's probably a good start, because that's all we do with differential calculus is work with derivatives. Otherwise, it's not part of differential calculus. So we have the derivative. If I evaluate the derivative at x equals -1, I get -8 plus 18 minus 7 minus 5. That is what, -2? -8 plus 18, 10, 10 minus 7, 3, 3, -2. So the tangent at -1, the tangent line, has slope -2. We want to find the x coordinates on the curve at which the tangent is parallel to that. Well, if it's parallel to this one, they have the same slope. So we want to find all points at which 8x cubed plus 18x squared plus 7x minus 5 is equal to -2, so that it has the same slope. In other words, 8x cubed plus 18x squared plus 7x minus 3 is equal to 0. Now, since I already have a point, since I already have a solution of this, i.e. the point -1, I know that x plus 1 is a factor of this. So I can do it algebraically. I can actually use synthetic division, if you're familiar with that, or long division. 8 comes down, multiply, add, multiply, add, multiply, add. And what I get remaining is 8x squared plus 10x minus 3 is equal to 0. And then this is a quadratic that I can use the quadratic formula for if it's not factorable. Maybe it is, maybe it's not. I don't know. I don't want to take the time to check. I'm going to go right to the quadratic formula. If you don't remember how to do long division or synthetic division, or you just don't know to do it this way, then graph it. You have a cubic equal to 0, solve for the zeros. We learned how to do that. But if you do, x equals -b plus or minus the square root of b squared minus 4ac, 24 times 3, what is that, 72 over 2a, 16. So 172 is not a nice number. It's not 72. What am I thinking? 4ac. I don't know what I was doing. 4 times a is 32. 32 times c is 96. That is a nice number. The square root of 196 is 14. In hindsight, it was factorable. -10 plus or minus 14 over 16. -10 plus 14 is 4. 4 over 16 is 1/4. And -10 minus 14, -24 over 16 is -3 over 2. Let's just do that with the calculator as well. Let's plug in y equals 8x cubed plus 18x squared plus 7x minus 3. Let's graph it. Don't forget to zoom standard, because from an earlier problem, we're way off the charts. So zoom standard. Oh, there it is. And I see 3 zeros. I'm going to zoom in, because I think if I zoom in, I can still keep all 3 in the graph. 1, 2, yeah, there they are. So we already have -1. So let's go to the far one and do second calculate 0. Let's start to the left of it. And then to the right of it. And yep, -1.5. And now let's do the other one, second calculate 0. Let's move my graph to the other one. Come around. There you are. Okay, just to the left, just to the right, guess, and we get 0.25, 1/4. And it said find the x coordinates, so we have the x coordinates and the test is done. So that was our test on differential calculus. The only one that was truly, I think, better an HL question than an SL question, even looking at the answer and making sure that it was listed as an SL question, was the one with that e to the power of, where it asks you to find where the derivative is the greatest, where the rate of change is maximum, and to eyeball it. Because the solution on the solution on the question bank, even though listed as an SL question, the solution certainly required the use of a second derivative, which is not an SL topic, which is why I gave full credit for those who eyeballed it and got the approximate answer without actually doing the math. Unfortunately, that wasn't anyone, but that's fine. you miss that, you miss 2 points, you can still obviously get a 7 if, if you really know this material well. Other than that, I felt the test was representative of what we had learned. A lot of derivative problems, just taking derivatives, understanding what a derivative was, tangent line problems, normal line problems. We had an optimization problem in there. Yeah, so that was it. So now I'm going to go quickly through the HL one. Hopefully I have time. So SL students, you can actually, you know what? I'll just do SL. HL, I'll do a different video. All right, so catch you guys later. Bye.